All right, today's lesson deals with a shorter, a quicker way of proving triangles are congruent. The other day, in section 4.3, we learned this little phrase, C, P, C, T, C, and we wrote out what those letters stand for. Basically, that is used when you know all the parts on each triangle. When I say all the parts on each triangle, I mean all three sides on each triangle and all three angles on each triangle, a total of 6 parts, angles and sides. That's when you know everything, but what we're going to learn today and tomorrow is that there are shortcuts. Today's shortcut is SSS, and that stands for side, side, side. Side, side, side congruence tells us that we don't need all the parts on each triangle anymore. We are good if we have a picture that looks like this. We know all 3 sides on each picture correspond and they are congruent. So I don't need the angles anymore. I don't need CPCTC when I know this much information. So it's a shortcut. You only have to know 3 pieces on each instead of 6 pieces on each. So we like that a lot. Later on, we're going to be learning some other ones, and you can see that on the posters in the front and back. There's one that's AAS, SAS, ASA. We're going to go through all those here before long. So it might not make a lot of sense now, but they will make sense later. Let's focus on this one, though. Talk about the sides and which ones are congruent. Let's make sure our letters correspond, make sure they match, and they're in the correct order. If I say segment AB, what does that correspond to on the other picture? A, B, R, S. Order matters in this case. Side BC is ST. Those are congruent. Make sure to put the congruent mark if it's not there, and make sure to put the segment mark on top. What about CA? TR. All right, so that should be short and sweet. They're in the same orientation, so you should see it really quick. Now you got to understand this little statement. What's this kind of thing called right here? What's it called? Congruence statement. Write that down. This is called a congruence statement. And they always look like that. Does the order matter on a congruent statement? Yes, order matters. And that's very important. Your order must be exact. What angle matches with angle A? R. What matches with B? S, and then T. They must match. Make sure they correspond. All right, example 1. It says write a proof, so we're going to go out to the margin and write it out there. They tried to do kind of a paragraph proof. We're not really going to use that format. We're going to use more of a 2-column format. Whenever we use a 2-column format, it generally is going to look like this. We have our statements on the left, and then we have our reasons on the right. Statements correspond with reasons. Now, the good thing is I'm not going to require you to do all the given and stuff on this kind of proof. So don't worry about the given too much. I want to focus on the actual reasons. So if you wanted to do given, all you would do is take this stuff, transfer it over here, and then write given. But this is, I'm going to call this kind of a mini proof for right now. We're not going to worry about the given. We're going to use it and then go from there. So first off, is the given information marked on the picture? Did it mark FJ and HJ? Yes, it's marked. All right, let's look at the second given. On the second given, did they mark anything for this? Do they have any marks dealing with midpoints or talking about labeling on those pieces? No, they don't. So, since G is the midpoint of FH, let's think about that. G is the midpoint of FH. G is the midpoint of this piece, FH. What does a midpoint do? Yes. Okay, it cuts it into two equal pieces, meaning this piece will be congruent to this piece. So that's what I'm going to write down. Anytime I write some marks, I put it over here. Where did I place marks? On FG and GH. They are congruent for what reason? Why are they congruent? What's the reason for that? Definition of a midpoint. Good job. Definition of a midpoint. So I use this idea to add marks. This is the reason for being able to do that. Next up, do I have all my sides marked like we've talked about earlier? No, I'm missing some marks. I don't have what side? The middle one, GJ, JG. So, is there a reason for putting marks there? Yes, there is a reason. Oh, that shared side. So let's write that note since some of you forgot. When you have a shared side, meaning they're back to back, they're stuck to each other, that's what you look for. I'm going to put that in parentheses. It's not really a reason. It's just a little reminder. When you see that shared side, that piece is going to obviously equal itself. JG will equal JG. And what property allows us to say that? Yes, the reflexive property. So that's what I'm going to write over here. So JG is congruent to JG because reflexive property. I forgot to write my marks. I should put triples on this one because I've already done the 1 mark and the 2 marks, so I'll put a 3 mark on that piece. Now do I have all the sides marked on each triangle? Yes. So once I have that, what's the reason that allows me to say they're congruent? When you have 3 sides on each, SSS proves the triangles are congruent. And they tell us the congruent statement. I'm going to use that over here. F, G, J is congruent to H, G, J. I just brought that over. Why did I not use CPCTC? Because I don't know all the parts. I don't know any angles. I can't use CPCTC because I know no angles. I don't know all the parts on the triangle. I only know sides. I know 3 sides on each. That's side, side, side. All right. Checkpoint number 1. On this one, you have to understand that it gives you a lot of information. It doesn't declare given is this. It just writes it on the picture. But remember, I'm not going to worry too much about the givens. I already know that these 2 are congruent because they're given. These 2 are congruent because they're given. I don't have that 3rd side. I don't have side, side, side because the 3rd side is not marked. But can I have a reason for putting a mark there? Is there a reason? Yeah. The reason for adding marks here is reflexive. And you've seen that this looks very similar to this one. They're sharing a side. These are sharing a side as well. So make sure to state reflexive property. Reflexive property allows me to say what statement? LK is congruent to LK, and these are both segments, so they need the segment symbols. Do I now have my 3 sides marked on each picture? So I now have enough information to say side, 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 and what's the statement that we're trying to prove? Yeah, it tells you right here. That's what you write. Triangle J, K, L is congruent to triangle M, K, L. This in green is all you needed, plus these marks on the picture. So here's how you'd get points. 1, 2, 3, 4, probably 5, 6 points there. Points over here, 2 points for marks on the picture, and then 4 over here. 2 for statements, 2 for reasons. That would get you your full total points. Number 2 is a little bit different. Remember today we learned about side, 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 so I'd be looking at that first. So do we have 3 side marks on each picture? Definitely not yet. The question is, can we add some marks somewhere? Where can I add marks? Raise your hand if you know. Donna, okay. Why can you add a mark on TV in RS? What's your reason you're going to give me from our poster? If you can't give me a reason, you can't add the mark. Anybody else have a reason? Definition of congruence just says it's an equal symbol and we're going to change it to a congruent symbol, or vice versa. Symmetric property will not help us in this case at all. You got to have something before you can use symmetric. So some other people have thought of some other reasons, but none of them are valid. Angles won't help because we don't have angles to begin with. We don't have vertical angles because it doesn't make a perfect X down here at this intersection, so we can't add angles. We're stuck. We have no reasons for adding that third mark on that third side. There's no third sides theorem. It doesn't exist. It's called third angles, not third sides. We're stuck here. So it says, decide whether the congruent statement is true. It's not true. This is false. And then it says, explain. Why is this false? We don't have enough information. Not enough info. Example 2 is similar to some stuff we've already seen in section 4.1. We're seeing graphs and triangles on those graphs. What do you all remember about the things you should be doing for graphs and triangles on graphs? What are some things you should be proving? Okay, so how do you prove right angles? For right angles, you have to prove what? Slopes. Slopes should be opposite reciprocal. All right, so that's one thing you can look for. What else should we be able to do when something is graphed like this? We made a list the other day based on type of triangle, based on side length. You need side lengths. And how do you find side lengths? Distance, Pythagorean, and you can count if it's along the grid. These are things you should be able to prove whenever something is graphed. Whenever something is graphed, you should be able to prove their side lengths, and you should be able to prove, is it a right angle or not? A lot of times that'll help. Today, since we're dealing with side, 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 we're not going to focus too much on the angles. We're going to just really focus on the sides. The question says, determine whether PQR is congruent to any others shown. So over here in the picture, we have PQR. And let's see, can I do any of these steps on PQR? What's the easiest? But easier than Pythagorean Theorem? Counting. So I can count right here. PQ I can count as 3, and I can write that. I can also count QR, and it is 5. I just need one more side, and how can I find that side? I can do Pythagorean Theorem because along the grid, that's going to be a right angle because those are opposite reciprocal. This is undefined slope, slope of 0. So I could write that down. Undefined slope and 0 slope is perpendicular. So I know that's a right angle. Now I can use Pythagorean Theorem. So we'll call this one PR. PR is the longest piece, therefore it's my hypotenuse. The other two we usually call A and B, those are the legs, so that's a 3 squared and a 5 squared. What's 3 squared? 9, and 5 squared is 25. 9 plus 25. And how do you get rid of squaring a term? Square root. So PR is going to be the square root of 34. That's like 5.8 something. Type that in real quick. 5.8. So we get 831. 5.831. That's all the stuff I need for the red triangle. Now we have two other triangles here. We have this one and we have this one over here. Which one do you all want to look at next? Which one kind of looks the closest? I think that one looks the closest. So RST is what I would do next. So once again, are we going to have this slope situation undefined? Yep, undefined is RT, zero slope is RS. So I basically repeat this stuff to say those are perpendicular. It's a right triangle. That means I can count if it's along the grid. That's a 3, and this is a 5. Guess what? RS is 3, RT is 5. We're going to end up that it's the same length. So you do ST squared based on the 3 and the 5. And I'm going to save a little time. ST will be the same length. Those two are the same. So I can say over here to the side, triangle PQR is congruent to triangle. How do I put that in the correct order? What matches with P? SRT. The question is that third one going to be the same? A lot of you are saying no, but you got to prove it. You only have to prove one part is wrong. So what do you want to prove? All right, I would pick VW as well. So let's focus on VW right here. We can either use distance formula or Pythagorean theorem, depends on what you want to pick. Okay. You can do that as well with Pythagorean. I'll show you real quick. I would pick Pythagorean. There's a triangle. It's a 1 by 3. So VW squared equals 1 squared plus 3 squared. You would get the same kind of stuff for distance formula. VW squared is 1 plus 9. VW is going to end up being the square root of 10, which is like 3 point something. Are any of these measurements up here 3 point something? Definitely not. So that one is not congruent. This is my final answer. Only the red and the blue triangles would be congruent. So we can prove these two are the same because we proved what about them? Side, side, side. That's the key fact on that one. We proved their side lengths match. We have our 3s, our 5s, and then both of their hypotenuse parts match. All right, here's the next checkpoint. They give you these ordered pairs. You got to be able to graph them. I had a few people that didn't graph correctly, so that caused them some problems. The next thing, make sure you label each vertex. So I have letters on all my vertices so we can talk about them. I like this kind of problem. You can pretty much guarantee that it's going to be on a test and or quiz. The first thing, when I'm thinking about congruence, side, side, side is generally one of the easier ones to prove, especially when you have sides that go along the grid. When they go along the grid, you can count them. So, a 2, this is 6, another 2, and a 6. And I can write those down. L, M is 6. M, N is 2. The only side I don't know on that triangle is LN. I don't know that side. I'm going to have to solve for that one. On the other triangle, I know DF is 6. I know DG is 2, but I don't know GF. That's the piece I'm going to have to figure out. Now earlier, we made it a right triangle. All right, quick change. You got to switch these letters around, make them match what I have. I didn't label them in the right spot, and that changed these two right here. So now we're back on track. So earlier we proved stuff about slopes in order to call these shapes right triangles. But really you don't have to do that if you make your own triangle to the outside. Generally though, if I see that two sides go along the grid, I'm going to try to prove that's a right triangle. So I'd see that this slope right here for ML is undefined. The slope for LN is 0. So these are slopes. I'm proving stuff about their slopes. Those are going to be perpendicular. I can do the same process for these. Now I can use these pieces to find the hypotenuse. So I'll say MN squared. That's always a hypotenuse goes out to the side. The longest piece must go out by itself. And then you have 6 squared and 2 squared. So we have 36 plus 4, and that's 40. The other stuff we're just going to bring down because we haven't touched it yet. So we have MN squared. And how do you get rid of squaring a term? Square root it. So I get MN is the square root of 40. And that's like 6.324? Or is it 324 or 325? 325. So make sure to round correctly. When it doesn't tell you how to round to 3 places. Make sure to round correctly. Same thing over here. So I would be saying GF squared equals 6 squared plus 2 squared. And I would still get GF is square root of 40. And that's also 6.325. This would be a good amount of work shown in order to say that these two pieces right here are the same. You can then say that the triangles are congruent. So I'll name the first one. I'll call it MLN. How can I make the other one match? What matches with M? L matches with D, and the last one, G. Why can I say this statement, though? I need a reason for it. This is because I've proven the sides. I've proven 3 sides on each picture are congruent. This would be your final answer, and this is your work to support it. Make sure to have all of that information. These are the big point problems on your tests and quizzes.